Okay, you should be able to see my screen.
Mm-hmm, mm-hmm.
Okay, so actually the question, let me move this out of the way. The question relates to when we compute the smoother matrix,
Right.
why do we do, for each x, we basically have a vector where only the element at that position is set to 1. Um, yeah, I kind of didn't understand that, and actually I just kind of wanted to back up and show you these notes to make sure I understand smoother matrix in the context
Mm-hmm.
of least squares.
Mm-hmm.
So for least squares, I basically can use, essentially this is the normal equations to get the hat matrix.
Right.
And then from that, the diagonals of the hat matrix, I can use that to compute the leverage of any single individual observation.
Mm-hmm.
X value. And like you can do the trace and you get the average leverage. So I think I got that for least squares. But then
Mm-hmm.
for these models, like the spline, I kind of want to understand, why
Why you're doing this?
yeah.
Yeah. Now, since you are sharing your screen, could you go to my previous office hour just yesterday? So you
Sure.
go to Saturday.
Yeah, let me go
Oh,
here.
it's the second. Oh, that's fine.
This one, right? No,
No, that's today.
this one.
Okay. And
Yeah.
could you open the office hour note slides?
Slides. Okay.
Now you can page down.
Okay.
Keep going, and because there's a formula I was talking about, leave one out, cross validation.
Yep.
Okay, here.
Yes.
Okay, good.
Okay.
So there's several models like you mentioned, linear regression, RAGE, or smooth and spline. And they all have this nice property where the predicted value y hat is equal to a matrix times y. For example, you already know for linear regression, the M basically the projection matrix, which I give the expression on the right. And if you do a RAGE regression, just plug in lambda plus identity before taking the inverse, right? And smooth and spline, if there is a basis function there, we also know how to get the expression. Now, something very interesting about this type of model is this matrix only depends on X, not depends on Y.
Right.
Me, I have my data X1, Xn, and Y1 through Yn. They're like, you can think about two columns, right? X1 through Xn, the first column, and Y1 through Yn in the second column. I sent them into my whatever black box. I get an M matrix, get the prediction. But that matrix itself only depends on X. So if I fit in a data where I with the same X1 through Xn, but my Y is going to be now in this particular screen, my Y1 is 1, or the others are 0, Y2 until Yn are 0.
Mm-hmm.
Once I send this into that black box and with all the parameters fixed, I should get the same M matrix. Now, once your Y is actually 1, 0, 0, 0, based on this matrix showing here, you're going to find out your Y hat will be the first column of the M matrix, and you fitted value. So in the sense that if somebody already built a model for me where I don't need to go to find out how to compute that matrix, but that black box, once I fit in data, they're going to give me the fitted value. If I only have such black box available, then I can retrieve that M matrix column by column by providing that X column with some specially chosen Y column.
Right.
So for example, in this case, the smoother formula, what I'm doing, I'm just trying to show that how to calculate leave one out cross validation. But in that smoother matrix, I basically loop through every time I give you the, the Y will be 1 at only one position and 0 at other places. Once I give that data into that black box, I look at the fitted value returned by the black box. They correspond to a particular column of the design matrix.
Yep.
Yeah, so this is how I piece up those columns together and piece them together, get the M matrix. So that's sort of the rationale.
Got it. Okay, I think it's simpler, and I think I was kind of maybe thought there was some mystery, but I think it's actually pretty simple. Okay,
Yeah, it is not difficult.
nothing.
Professor, one question over here. So,
Mhm.
Professor, is it like that we have to apply this particular trick to retrieve the M matrix because R doesn't by default give out the M matrix?
Yeah, R does not yet did not give
Also,
us the
this
matrix.
is our computational way of finding M matrix once the model is fitted.
Right. So for smooth and spline, I don't think the basis functions are like, I don't know how to get it from R. Maybe the original smooth and spline fitting is written in Fortran or other language. Now for low is again, it's doing kind of a lot of a local linear regression, and you don't want, you could sort of loop over and find out the, that matrix and at each one of them and try to solve that one, but it's not worth the effort since you have this easier way to get the smoother matrix through this approach. Okay, so let me see.